The first part of the question is asking, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So when it's talking about gaining weight faster, it's talking about the derivative, which is dB over dt. So first we're going to calculate what dB over dt is when b is equal to 40. So if we put 40 in the equation that we are given, we get 1 over 5 times 60, which is equal to 12. Now if we do the same thing for when b is 70, to calculate dB over dt when b is 70, we get 1 over 5 times 30, which is equal to 6. In these AP questions, you need to write clear definitions. So you need to say that dB over dt when b equals to 40 is bigger than dB over dt when b equals to 70. Since the derivative is bigger, then it means that the bird gains weight faster when it weighs 40 grams. And you need to write this down as clear as possible. The first part of the question at B is to find the second derivative of the function b. So the second derivative would be equal to the derivative of the first derivative. So we take the derivative of dB over dt, which we are already given. So we take the derivative of 1 over 5 times in parentheses 100 minus b. So when we take the derivative, the 20 goes away and we get negative 1 over 5 dB over dt. Now we know what dB over dt is already, so we put that instead of dB over dt, and when we calculate it, we get negative 1 over 25 times in parentheses 100 minus b. So this is the second derivative. Now the second part of the question asks us to explain why the graph of b cannot resemble the following graph. So, when we talk about the second derivative, we are talking about the inflection points, the change of sign of the derivative. So if we write this down, then we can see that it will always be negative when b is smaller than 100. Then we need to state this, and then we say that since it's always negative up to when b is 100, the graph will always be concave down in that interval, which means that there will be no inflection point in the graph from 0 to 100. But when we go back and look at the sketch, we can see that there is an inflection point there because the derivative changes its sign. The second derivative changes its sign. So at first the derivative is increasing, but then the derivative starts decreasing. This means that there's an inflection point there, and we proved that there cannot be, so we explained that it cannot resemble that graph. In the C part of this question, we are asked to use the separation of variables in order to find y equals bt. So, we write the equation that we are given, which is dB over dt is equal to 1 over 5 times, in parentheses, 100 minus b. Now, we take the dt to the other side, and we take 100 minus b to the other side, so that the b's are together and the t is alone on the other side, and we put integral signs in front of both in order to take the integrals of both. So, when we take the integrals of these, we get a minus ln in absolute value, 100 minus b, equals to 1 over 5 times t. There is a plus c on the both sides of the equation, but we can just combine them and write 1 plus c at the right side of the equation. So now, in order to get rid of the absolute value, we can say that since b is between 20 to 100 in the question, since b is always in that interval, 100 minus b will always be positive, so we don't need the absolute value, and we can just say 100 minus b in that case. So now we need to find what c equals to. We are given an initial condition and we write it as it is. So we get negative ln 100 minus 20, which is b, and then equals to 1 over 5 times 0, according to the initial condition that we are given. And if we calculate it, we get negative ln 80 to be c. So now we put this value for c, and we write our equation again, which is negative ln in parentheses 100 minus b equals to 1 over 5t minus ln 80. Now this is our equation. So all we need to do right now is to leave b alone. So 100 minus b is equal to 80e to the power negative t over 5. If we calculate this, and if we take a look at the background of it, if we take ln 80 to the other side, we get ln 80 minus ln in parentheses 100 minus b, and according to the properties of logs, we get ln in parentheses 80 over 100 minus b. So that is where these come from. Now, since we are turned the equation into this, we're gonna work with this to leave b alone. So bt is equal to 100 minus e to the power negative t over 5.